In this lesson, I'll teach you how to expand logarithmic expressions using logarithm laws. The question reads, use properties of logarithms to expand each logarithmic expression as much as possible. We start with question A, where we have log of base 7 and this expression found in these parentheses. One of the laws of logarithms states that if you have multiple factors inside here, you can separate them as a sum of logarithms to the same base, 7 in this case. So since we have a factor 49, x to the power of 3, and the fifth root of y to the power of 2, we can write this as a sum where we have log base 7 of 49 plus log of base 7 x to the power of 3 plus log of base 7 the fifth root of y to the power of 2. We'll start with this term, log of base 7 of 49. That's the same thing as saying, well, if we set this equal to y, that's the same thing as saying 7 raised to the power of y is equal to 49. What can y be so that this equation holds true? And the answer is 2. So all of this becomes 2. For this, you'll notice that x to the power of 3 has an exponent. One of the logarithm laws tells us that if you have a value raised to a power, you can actually write this 3 as a coefficient of that term. Therefore, rather than the following, we can write down 3 times log of base 7 x. And for this, well, the fifth root of y to the power of 2 is the same thing as saying y to the power of 2 raised to the power of 1 over 5. So technically we have an exponent again. We can rewrite this as 1 over 5 log of base 7 y to the power of 2. The same logic that we applied here is applied there. So now we have a coefficient of 3 and a coefficient of a fifth. Of course, we can apply that once more with y to the power of 2. The base y has a power of 2, so that 2 will come at the front where it becomes 2 over 5 log of base 7y. So let me rewrite this, 2 plus 3 log of base 7x plus 2 over 5 log of base 7y. If you wanted to, you could have coupled that last step, the one from here to there, into one step by multiplying 2 and 1 over 5 together using the exponent laws, and have skipped a step by doing that. For question B, we have ln of the expression found here. Remember, ln is the same thing as log of base e. It's just a different symbol that we use. So the same logarithm laws apply to B as they did to A. One of the laws that we didn't use in A but we are using in B is that since this is a quotient, you can actually break this expression down as a difference of two lns. So I'll write down ln for the numerator alone minus ln of the denominator alone. Okay. For this term, you have to be a little clever. X to the power of 2 minus 4 is a difference of squares. And it can be broken down into x minus 2, x plus 2. That's significant for us because that's a product, and we can use the logarithm law to break this down into a sum. So we have ln of x minus 2 plus ln of x plus 2. So this new expression right here replaces this one. For this one, we have two factors, 9 and e. So I'll use that very first law that we applied and write it down as a sum. Ln of 9 plus, and before I continue, I'll place this in brackets because of this negative. The negative will apply to both terms that we've created, that we've expanded. Ln of base e raised to the power of x to the power of 3. Now, whenever you have log of base e to e, when these two are the same, it becomes 1. And that's the case right here. We have ln of e. At the same time, e is being raised to x to the power of 3, which will default to its coefficient position. Technically, we have ln 9 plus x to the power of 3 ln e, which we just learned, becomes 1. So our expression is ln x minus 2 plus ln x plus 2, distributing this negative to both terms on the inside, minus ln 9 minus x to the power of 3. So what you see right here is the most expanded that original expression will go. And there you have it. That is how to expand logarithmic expressions using logarithm laws.